Chances are you're watching this on your phone right now. But have you ever really stopped to think about how a web page gets from some massive server farm all the way to the palm of your hand? Well, today we're going to pull back the curtain on the 6 clever architectures that actually make the mobile web work. Let's dive in.
And this is a huge problem, right? The very DNA of the web, things like HTTP and HTML, they were all designed for beefy desktop computers with stable, super fast connections. Your phone? It has, well, none of that. It's got a small screen, a battery that's always dying, and a connection that can drop out at any second. So how on earth do you bridge that gap? That's where some really brilliant system architecture comes into play.
You know, at its core, the web is pretty simple. Your browser is the client, and it asks a server for a web page. That's it. But for mobile, there's one magic ingredient that underpins everything: caching. The simple idea of storing data locally so you don't have to download the same stuff over and over again. And that one concept, it's the foundation for everything we're about to talk about.
All right, so the first batch of solutions took a really direct approach. The thinking was pretty simple. If the network is slow and unreliable, let's just make the phone itself smart enough to deal with it. We're talking about putting all the intelligence right here on the device without touching the servers or the network at all. So, what's the most straightforward way to do that? Well, you just bake all those smarts directly into the browser itself. This means the browser is doing all the heavy lifting, things like advanced caching, prefetching links it thinks you're going to click on next, and managing everything from when you inevitably go offline. If you remember some of the early versions of Internet Explorer, you've seen exactly this in action.
And you can see from this diagram just how clean that approach is. You've got your phone, the mobile client, and inside it, the browser and all its enhancements are just one single unit. It talks straight to the web server. No fuss, no muss. It's simple, it's self-contained, but what if you wanted to make it a little more modular?
Okay, so what's the next logical step? You unbundle that intelligence. Instead of building everything into the browser, you create a totally separate helper app that runs on your phone. This little application just works alongside your main browser, doing all that hard work of fetching and caching content for you. The classic example of this was a program called WebWack.
Now, what's really cool about this diagram is you can see the two working in parallel. The browser is doing its thing, making its requests, but that additional app also has its own direct line to the web server, proactively grabbing stuff. It's kind of like having a personal assistant in the background, just getting things ready for you before you even ask.
Now, our third client-side model introduces a really powerful concept, the proxy. In this setup, a client proxy runs on your phone, but instead of just working next to the browser, it sits right between the browser and the network. It literally intercepts every single request that browser tries to make. So look at the data flow here, because this is the key. The browser thinks it's talking to the internet. It's not. It's only talking to this client proxy. And then the proxy gets to decide, do I have this in my cache already, or do I actually need to go out to the real web server? This gives it a ton of control.
Now, these client-side solutions are pretty clever, but they put all the strain on your phone's little processor and its battery, which, leads to a pretty big question. What if we could move all that heavy lifting off the device completely? And that brings us to our second big idea. Let's introduce a powerful helper inside the network itself. Now, this is where things get really interesting, especially if you're trying to deal with a truly terrible connection.
This architecture totally flips the script. Now, a powerful server, a network proxy, is sitting somewhere in your mobile provider's network. Its whole job is to grab a web page from the internet and then just completely transform it. We're talking shrinking images, simplifying text, you name it, before it even sends that tiny optimized version over the air to your phone.
Let's just trace the path on this slide. The phone talks to the network proxy. The proxy goes out and does all the hard work. It talks to the web server, it caches, it optimizes everything, and then it sends a super lightweight, easy-to-digest version back to your device. For slow networks, this is an absolute game changer.
So we've seen solutions that put all the smarts on the phone, and we've seen solutions that put them in the network. So the final two architectures ask a pretty simple question. Why not do both? These are the hybrid models, and they're all about getting maximum efficiency by combining the two approaches.
So let's see how this all comes together. Both of these final models have the exact same core idea. You've got a client proxy living on the phone, and it's working hand in hand with a network proxy that's out in the network. They're literally designed to talk to each other and cooperate.
And the benefits here are just huge. I mean, because these two proxies can talk to each other, they can use their own special, super efficient language, not the clunky standard web stuff. So the network proxy can do the heavy lifting of transforming content, while the client proxy handles all the intelligent local caching. It's honestly the most powerful and flexible approach we've looked at.
All right, we have covered a lot of ground here, from simple little browser tweaks all the way to these complex, cooperating proxies. So let's try to pull it all together into one final takeaway. So here it is, our 6 architectures at a glance. We started with 3 approaches that are all about the client, either building the smarts into the browser, using a separate helper app, or using a local client proxy as a middleman. Then, we moved that intelligence into the cloud with a network proxy. And finally, we got the best of both worlds by combining them, sometimes even giving them their own special protocol to chat with. But at the end of the day, despite all their differences, every single one of these architectures is chasing the exact same 2 things: fighting latency, that's lag, and saving bandwidth. They all just try to do it by being really clever about prefetching data, caching it, and transforming it to make it smaller and faster.
And that leaves us with one final thought to chew on. We always assume that faster networks like 5G will just make all these tricks obsolete. But will they? As we all demand richer, more complicated content on our phones, which of these roles, the local cache manager on your device or that powerful content transformer out in the network, is actually going to become even more important? Let me know what you think. Thanks for watching.